Hi guys, let's look at the next question. The next question that we're doing is question number 9. Base of a triangular field is 3 times its height. Okay, so base is 3 times its height. Perfect, so approximately something like this. And let's draw the height as well. So this is the height. Perfect, so let the height be x. Therefore, the base is 3x. Let's give it some name as well. A, B, C and D. Good. So let height is equal to AD is equal to x meter. Now they're talking about meter in everything. So therefore base is equal to BC is equal to 3x meter. Perfect. Cost of cultivating the field at 36 rupees 72 paisa for 100 square meter is something. Also basically we are using unitary method. 100 square meter cost 36 rupees 72 paisa. So this much money was used to cultivate how much land. So that will give us the area of this field. Good. So we figure that out. So that will give us the area. So let's do that. Rupees 36.72 is cost of 100 square meter. Therefore, rupees 49,572 is cost of how much? Cross multiply, which is 49,572 into 100 upon 36.72 square meter. Perfect. Therefore, area of triangular field is equal to 49572 into 100. I'm multiplying it with 100 again, numerator and denominator, so that I can remove these decimals. So this would become 3672. And we know area of a field is equal to area of a triangle is equal to half into base, in this case 3x, into height, in this case x, and that's equal to 49572 into 1 with 2 0 and 2 extra 0. That's 4 zeros upon 3672. Now I will have to multiply and divide in any case. So that's x square. This is 49572 multiplied with 1 with 4 zeros multiplied with 2 upon 3672. Let's divide. So into 3, sorry, because this 3 goes down here. So that's 3. So 3 1 and this is 3 1 3. That's 8 19, 6 18. That's 5 2 and 4. Good. Now let's divide this with 9. That's 9 and 9. This is 6 9 9. Yes, I hope you remember the divisibility test of 9. If sum of all digits is divisible by 9, then the number is divisible by 9. So this will be 9 into 4, 0 and 8. This would be 9 into 1. That's 75. 9 8s are 72. That's 32. 9 3s are 27. And that's 54. So that's 9 6 are 54. Good. This would be divisible by 3. Yes. So 6 now. So 6 6 are 36. That's 48. That's 68. And this will be 6 3s are 18. 0 and 6. So 306 divided by 68. Now we will divide this by 2. Yes. 34. And this would be 153. So let's divide 153 by 34. Don't seem to have any common factors now. So 153 divided by 34, that'll be 4. So that'll be 120 and 16. That's 136. 120 and 16, 136. That 13 minus 6, 7. That's 4 minus 3, 1. I'll put a decimal, which means 0. That's 170. That's 5. 120. Yes, 170, that's fine. So my answer is 4.5. So 34 1 and 34 4.5. Long calculation. Let's just erase what I wrote here and it'll give me some space to do my work. Good. So x square is now equal to 4.5 into 2 into 1 with 1 2 3 4 zeros and nothing in the denominator. So x would be equal to, this is 9. So that's square root of 9, and this would be 100 into 100, which means out of this 100 comes out, of this 3 comes out, so this is 300. And what was the unit we took? Meter. So x is equal to 300 meter. So and 3x would be equal to 3 into 300, that's 900 meter. Therefore base is equal to 900 meter and height is equal to 300 meter. Interesting question. Used first the formula of first used ratio, next used unitary method, and then used area of a triangle. Perfect. Let's look at the next question. The next question that we're doing is question number 11. Question 11 says each of equal sides in an isosceles triangle is 4 centimeter greater than its height. Okay, so rough diagram for clear understanding. So each equal side is 4 centimeter height greater than the height. So these are the two equal sides. Let's make the height as well. Okay. So whenever a height is mentioned, we usually mention in an isosceles triangle the height which is coming onto the base. Perfect. Let's give this some name: A, B, C, and D. 4 centimeter higher than it's greater than the height. Let height is equal to AD is equal to x centimeter. So if this is x, then each equal side, therefore each equal side is equal to x plus 4 centimeter. So this is x plus 4 and this is also x plus 4. Done. If the base of the triangle is 24 centimeter, so BC is given equal to 24 centimeter. Calculate the area and perimeter of the triangle. So we've done a question like this before. Since altitude of an isosceles triangle divides base in two equal parts, therefore BD is equal to CD is equal to BC upon 2 is equal to 12 centimeter. So BD and CD are equal and they are equal to 12 centimeter. Perfect. So now in triangle ABD, using Pythagoras theorem, we get hypotenuse square, in this case x plus 4 square is equal to sum of the other two sides. So a square of the sum of other two sides, so that's x square plus 12 square. Let's open this becomes x square plus 16 plus 4 into 2, that's 8x is equal to x square plus 12 square, that's 144. X square gets cancelled on both sides, which means I have 8x is equal to 144 minus 16. 8x is equal to 128. Therefore x is equal to 8 ones are 8, that's 48, 16. So x is equal to 16 centimeter. What do they want us to calculate? They want us to calculate the area and perimeter. So therefore height is equal to 16 centimeter and each equal side is equal to 16 plus 4, that's 20 centimeter. So this is 20, this is 20, and this is 16. Perfect. So therefore area of triangle ABD is equal to area of triangle ADC. These two are basically congruent triangles, and their area will be equal to half into base, in this case 12, into height, which we calculate as 16 square centimeter. So 2 1 2 6, that's equal to 96 square centimeter. So that's the area of one triangle. Therefore area of triangle ABC would be equal to 2 into 96 square centimeter. Therefore area is equal to 96 into 2, that's 180, and 12, that's 192 square centimeter. Done. So we've calculated the area. Next is perimeter. Perimeter would be equal to sum of three sides. So that's 20 plus 20 plus 24 centimeter. That's 246, 64 centimeter. Perimeter is 64 centimeter. Good, interesting question. Again, I hope you realize that in an isosceles triangle, the altitude is equal to the median as well. Good, let's look at the next question. The next question that we're doing is question number 13. So it says in triangle ABC, angle A is equal to 90 degree, AB is equal to X, AC is equal to something, area is equal to something. Find the sides of the triangle. So let's rough diagram. Since it's a right angle triangle, let's look at a rough diagram first. So angle A is 90, let this be B and let this be C. So AB is equal to X. So this is X, AC is equal to X plus 5. This is X plus 5 and area is equal to 150 square centimeter. So area we know is equal to half into base into height, which means in this case area is given equal to 150, which is equal to half into AC. AC is X plus 5 and AB is X. Let's cross multiply. This will give us a quadratic. We will have to solve the quadratic. Good, let's move on. So 150 into 2, that's 300, is equal to x square plus 5x, which means x square plus 5x minus 300 is equal to 0. I need to find factors of negative 300, the sum of which is 5. This one's simple. We've done this one enough number of times. So that's x square minus 15x plus 20x minus 300 is equal to 0. The factors of 300 are 15 into 20 and negative 15 plus 20 would give me plus 5. Perfect. Let's group this in this manner and I will have x times x minus 15 plus 20 times x minus 15 is equal to 0, which means x minus 15 times x plus 20 is equal to 0, which means x is equal to 15 or x is equal to negative 20. Since length can't be negative, therefore x is equal to negative 20 is not possible. Length cannot be negative. So then this is rejected, which means x is equal to 15. Good. Let's read the question. What do they want us to calculate? Find the sides of the triangle. Therefore, AC is equal to x plus 5, that's 15 plus 5, 20 centimeter. AB is equal to x, which means 15 centimeter. We still need to find BC. I notice again this is a 3, 4, 5 triplet. 5 into 3, 5 into 4, that would be 5 into 5. Anyway, let's use Pythagoras theorem. Using Pythagoras theorem, BC square is equal to 15 square plus 20 square. 15 square is 225, 20 square is 400. Therefore, BC is equal to square root of 625 centimeter. Therefore, BC is equal to 25 centimeter. Therefore, sides are 15 centimeter, 20 centimeter and 25 centimeter. Done. Again, use two concepts. First area, then applied quadratic, and then eventually applied Pythagoras. Very interesting question. Let's look at the last question that we solve in this exercise, which is question number 15. Question 15 says AD is an altitude of isosceles triangle ABC, in which AB is equal to AC is equal to 30 centimeter and BC is equal to 36. So let's just draw a rough diagram. So this is my isosceles triangle and that's the altitude that we've drawn. Good. So AB and AC are equal, which means A, B and AC are equal and they are equal to 30 centimeter. This is 30 centimeter. This is altitude. BC is given as 36 centimeter. AD is the altitude. Done. O is marked on AD such that angle BOC is 90. So there is a point somewhere here, let's say here, which is point O, in a manner that angle BOC is 90 degree. Perfect. So I think I've got my rough diagram correct. Angle BOC is 90 degree. We need to find the area of quadrilateral ABOC. Oh, so we have a ABOC quadrilateral. We need to find the area. How would we be able? So if I can shade it, we need to find this area. So this area would be equal to maybe the area of the big triangle minus area of this small triangle BOC. So if I can calculate the area of the big triangle and then subtract the area of the small triangle from it, I should be able to get an answer. So let's look at this. In an isosceles triangle, altitude is equal to median. Therefore, BD is equal to CD is equal to BC upon 2 is equal to 36 upon 2, that's 18 centimeter. So BD and CD are equal and they are 18 centimeter each. Perfect. So now I can figure out either the area of this triangle using Heron's formula, which is 30, 30 and 36, or if I remember the formula, which was 1 by 4 into B into 4A square minus B square, and then calculate the area using the special formula of a isosceles triangle, or maybe I can use the Pythagoras theorem to calculate length of AD and do it. Whichever way I do, let's look at it. So I would use the Pythagoras theorem and use it. Okay. So in right triangle ABD, using Pythagoras theorem, 30 square is equal to 18 square plus AD square. 30 square, that's 900, minus 18 square. 18 square is 324. Yes, 324 is equal to AD square. That's 576. Yes, that's 576 is equal to AD square. Therefore, AD is equal to square root of 576. So square root of 576 is 24, or is it 26? 24. So AD is equal to 24 centimeter. Next, we will calculate area of triangle ABC, which would be 2 times the area of triangle ABD, which means half in 2 times, sorry. So 2 times the area of triangle ABD, which means 2 into half into base, in this case 18, into height, in this case 24. So 2 and 2 gets cancelled. So that's 24 into 18. I will leave my answer here. I will not do the calculation further. Maybe I will be able to solve it without doing the calculation, because this will require some calculation. Next, let's look at the triangle OBC and see if I can get something. Well, obviously these triangles are again congruent, but we'll still have to prove it. So in triangle OBD and triangle OBC, what do we have? Number 1, OD is equal to OD. This is common. Why am I trying to prove this congruent? Let's see. We will figure out how will it help us to prove these congruent. Next would be, because I will get the area of one triangle, and that will help me get the area of the big triangle OBC. Number 2 would be BD is equal to CD is equal to 18 centimeter. We've already proved this. And number 3 would be angle ODB is equal to angle ODC is equal to 90 degree, since AD is perpendicular to BC, since AD is the height, which means therefore by side angle side test, triangle OBD is congruent to triangle OCD. What this gives me is that these two triangles are congruent. Perfect. So let's see how will this help me get the area of this triangle. So let OB is equal to OC. So this will give me OB is equal to OC. Let OB is equal to OC is equal to X. The reason for this is CPCTC. So OB is X and OC is X. So this is an isosceles triangle with the base 18. So I can use Pythagoras theorem to calculate the value of X. Or maybe I can use the area of a isosceles triangle. Let's use Pythagoras theorem. So using Pythagoras theorem, x square plus x square is equal to 36 square, which means 2x square is equal to 36 square. Next, x square is equal to 36 into 36 upon 2. That's 2 1 and 2 18. X would be equal to square root of 36 into 18. I'm writing it as 9 into 2. So out of 36 6 comes out, out of 9 3 comes out. That's 18 root 2 centimeter. So value of X is 18 root 2 centimeter. Next, I'll find area of triangle OBC. Area of triangle OBC would be equal to half into base, in this case 18 root 2, multiplied with base height, in this case 18 root 2 once again. Perfect. 2 1 to 9. So this is 9 into 18 into 4. 9 into 18 into 4. That would be, I could have left it like this only. I did not need to calculate X because area would be X square in any case. Anyway, so now that we've done this calculation, this would be 9 into 18 into 4. So that's 18 into 30. 18 into, why 4? This is root 2 into root 2, 2, not 4. My mistake. This is 2. My mistake. Out of this, let's see this again. This is out of this 9 into 18, and the root 2 into root 2, that's root 4, which is equal to 2. So this would be 18 into 18. Calculation error, but I'm glad I realized it at the right time. 18 into 18 square centimeter. Therefore, area of quadrilateral ABOC equal to area of big triangle, which is ABC, minus area of small triangle OBC. Area of big triangle, we got it as 18 into 24 minus 18 into 18. 18 common, that's 24 minus 18. That's 18 into 6, which is 108 square centimeter. Therefore, area of the triangle is 106. So area of quadrilateral is 108 square centimeter. I have no place to write my final answer, so let me just write it in a separate place here. Let me just make a border here and let's write the answer. Therefore, area of quadrilateral ABOC is equal to 108 square centimeter. Interesting question. Let's look at how we did it. First, we calculated the length of AD that helped us get the area of the big triangle. Then we found the value of X, which got us the area of small triangle, and then we subtracted. Perfect. That brings me to your homework questions. Homework questions for today are question number 11, question number 10, question number 12, and question number 14. That finishes this exercise for us. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.